This is your 2.3 notes on histograms. We use a histogram to analyze the shape of your distribution, meaning that you can see visually where your data falls. It's basically like a visual display of a frequency distribution, and it's a bar graph. I mean, it's a normal bar graph that you've seen before, but they typically don't have gaps in between them, and the heights of the bars represent the frequency or relative frequency depending on what type that went with your data. So this was our example from last time. We have pulse rate 60 to 69. Alright, if we used class boundaries, 59.5 is 1/2 below the 60. 69.5 is between the 69 and the 70. That one has a height of 12. Okay, and then 70 to 79, that's 69.5 to 79.5, that had a height of 14. So this is just like what we saw in the last notes. We made this frequency distribution, and now this is the visual of that. So this is going to be 11, and then these are my 1s, and this is a 0, obviously. No height at all there. Alright, so same thing as a frequency distribution, is just a visual for it. Okay, again, notice there's no gaps between the bars here. Alright, and then the labels that we use, typically we use class boundaries. This one used class boundaries. The 59.5 to 69.5, that's the class boundaries that we talked about last time. We can use class midpoints, so I could have used right here, instead of 59.5, 69.5, I could have used a 64.5 like we computed on the last video. Alright, and then lower class limits introduce a small error. We don't typically see that. Usually we see one of these two things. Alright, and then your horizontal scale, on the horizontal scale is the numbers going along this rate. That is your classes. Whatever your classes are always going to be going left to right. And then your vertical scale is either going to be frequencies, or if it's a relative frequency histogram, you could use relative frequencies. Alright, and that's this example. So instead of this being 12 like it was before, it's 12 out of the total of 40, which was 30%, so it's going up to 30% there. Okay, and if you notice that the bars here are identical, okay, the heights and where the bars fall, the only thing that changes on a relative frequency histogram from a frequency histogram is just what these heights go to. Instead of going to 12 and 14, they're going to 30%, 35%. Okay, but same exact thing. You just make the heights of the bars go to where the relative frequency is instead of the frequency. Alright, this is another review of the bell shape. We're going to use the bell-shaped curve a lot in this course. So again, if you see the frequencies increase to a maximum and decrease, if they go up and peak and come back down, and there's symmetry when it does that, meaning it doesn't peak too soon and then take a long time to go down, or take a long time to peak and then go down really quickly. If the way that it rose and then fell is symmetric, then you're looking at a bell curve. So this next histogram example is something that looks like a bell-shaped curve. Now, even though this is the peak and there's 3 bars to the left and actually 4 bars to the right, it still rises, peaks, and is roughly symmetric if we folded it over. So this is suggesting bell-shaped data, even though it's not perfectly symmetric. Okay, you're taking sample data, it's rarely going to be perfectly symmetric. Alright, and just to recap, histograms, relative frequency histograms we discussed, bar graphs, typically no gaps between them when we're doing a histogram, and then the heights of histograms and relative frequency histograms are the same, they've just been scaled down because one's in percentages and the other's not. Alright, pretty straightforward section. If you have any questions about it though, give me an email. and we'll get together and work on some stuff.